Now we're going to run through several concentration examples with some soda. If we look at Pepsi Throwback, it has 67 grams of sucrose, that's table sugar, along with other ingredients dissolved in enough water to make 591 milliliters of Pepsi. So that is our solution. And we're going to try to determine as many concentration units as we can. So in this case, Pepsi represents the solution, and our sucrose is one of the solutes. And the density of soda is a little bit heavier than water. All right, so let's take a look at all the components of our solution here. The solution is made up of the solute and the solvent. They are added together to make the solution. We know that we have 67 grams of sucrose, and we know that we have 591 milliliters of solution. And if we take that milliliters of solution and use it with the density, we can get the grams of solution. The density, in this case, is the density of soda, and it is only a property of the solution. We cannot use that with the solute. We cannot use it with the solvent. We can only use it with quantities, either the mass or volume of solution. So the 591 milliliters of solution times 1.045 grams of solution over milliliters per milliliter of solution gives us 617 grams of solution. All right. Because I know the solution, the total solution, I can subtract out the solute to get the solvent, because the solute plus the solvent equals the solution. So if I subtract out the solute, I can get how many grams of solvent. And then I can take the 67 grams of sucrose, use the molar mass, so look up the C12H22O11 and get the molar mass of sucrose. And I'll go ahead and write that number in here. The molar mass is 342.3 grams per mole. So that's the molecular weight of sucrose. And if you convert that, you get 0.19573 moles. What else can we determine here? Let's see if we have enough information to do a percent mass. So we need the part over the whole. We have the mass of the solute, and we have the total mass of the solution. So mass of solute over total mass of solution times 100 will give you 10.85%. All right, let's move on. For mole fraction, that's going to be much harder. There's a lot of other ingredients in Pepsi, so we really can't calculate the total moles here. We could do a brief calculation and calculate the moles of sugar and the moles of water and add those together to get a mole fraction, an approximate mole fraction, but again, there's a lot of other ingredients, so it would be hard to do the total moles here. All right, so let's try molarity. Molarity is moles of solute over liters of solution. All right, so we have already calculated the moles of solute because we have the 67 and we could use the molar mass to get the moles. We have the milliliters of solution, so we can convert that to liters, so divide by 1,000. You're going to get 0.591 liters of solution. So when we put that together, we get 0.3312 molar for the concentration of sucrose in Pepsi. And our last unit is molality, so let's see what pieces we need for that. Molality is moles of solute, which we have, over kilograms of solvent. So we determined that earlier as well. So we had the total moles of solution, which we determined by using the volume of solution with the density of the solution. So we have the total moles of solution. If you take the total moles and subtract out the solute, then you're left with the solvent. And then you can convert this to kilograms by going back 3 spaces, dividing by 1,000. So you have 0.550595 kilograms. And when you do the solute over the kilograms of solvent, you get 0.3355 moles.